we're doing day 3, area and perimeter. We did area and perimeter last chapter. This chapter, we're going to talk about doing it on the coordinate plane. So the first thing we need to do is graph our ordered pairs. This is your x-axis, this is your y-axis. So -3, 1, 2, 3, down 1, 2, 3. This is point D. Point E is 0, 2. F is 6, -3. Okay, and you can draw your triangle here. Sometimes the pictures might be given to you. On these first couple we have, I'm actually just graphing points because you never know, you might have to be able to graph points. It's not a bad concept to review again. Okay, I'm going to start with area because in this particular picture, the area formula is 1/2 base times height, and you want to look at where something is exactly 90 degrees to figure out a base and height. In this particular picture, I'm going to extend this line down and create this 90-degree corner with the bottom of the picture there. So to find the base, we just need to count some blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our base is 9. Our height is 5. So 9 times 5 equals 45, and half of 45 is 22.5. Perimeter is finding the length around something. Well, you'll notice on these DE and EF are both diagonal lines. In order to find the length of a diagonal line, you have to use the distance formula. So we're going to use the distance formula to find the length of DE. So you do your x's first. That's 0 minus -3. Makes it a plus. And 2 minus -3 makes it a plus. So that gives me 9 plus 25 equals the square root of 34. On this particular one, it says we're rounding to the nearest tenth, so I'm going to go ahead and take the square root of 34 is about 5.8. Okay, now we're going to, can't see that. We're going to find the length of EF. So that would be 6 minus 0 squared plus -3 minus 2 squared. That gives us 6 squared is 36. -5 squared is 25. And if I add those together, I get the square root of 61. So we need decimal form of that. Rounding it, I'm going to get about 7.8. So your perimeter is adding up all those sides. So in the picture, I'm going to say this one is 5.8. This one is 7.8. So 5.8 plus 7.8 plus 9 equals 22.6. And on these we don't have any measurements, so you could call it units or units squared, but we'll just leave it at that. Next one, we're going to draw a trapezoid. So this is reviewing a lot of our formulas we did last chapter. Just again applying it to the coordinate plane, so you have to find lengths a little different than we did last chapter. So let's plot our picture. -2, 3. 1, 3. 4, -1. And -4, -1. So this is our trapezoid. Good line. Sorry guys. Main thing is you have the points graphed correctly, not that my lines are perfectly straight. Okay, so we can do area first if we want. If I was going to draw in something perpendicular here, I would say this has a base of 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to say 8 is its base. We have a height of 1, 2, 3, 4. And our other base is 3. So the area formula for a trapezoid is 1/2 times the height, and then base 1 plus base 2. Again, a formula we used last chapter. Going to need to know for this chapter. I'll do 1/2 times 4 times adding my bases together, 3 plus 8. Now 1/2 of 4 is 2, and that's 11, so we'll say this is 22. Perimeter, I need to find the diagonal lengths of like AD and BC. If I look at this picture, they don't look the same size. So I'm actually going to do two distance formula again on this to find the length of AD. So my x's, let's see, A and D. So my x's are -4 minus -2. And then -1 minus 3. This gives me -2 squared would be +4. -4 squared is 16. And that equals square root of 20. I'm going to get my calculator. Square root of 20, because we're doing decimals on this, is about 4.47. So we'll say about 4.5. And then we have BC. Find the length of that one. X's are first, so 4 minus 1 squared plus -1 minus 3 squared. That's 3 squared is 9. -4 squared is 16. Well, square root of 25, well, that's a nice one. That's just 5. Alright, so in the picture, I'm going to write this side was 4.5, and this side is 5. So we're going to find our perimeter. So I'll add these numbers together. 3 plus 5 plus 8 plus 4.5 equals 20.5. So using our area formulas for before and using distance formula to help us find the perimeter. This one, they didn't give you the ordered pairs. So if they give you a picture, can you take a picture and figure out the ordered pairs in order to do the formulas? The reason this one says find perimeter only because this is not a equilateral polygon, it's not a regular polygon, so we're not asking you to find the area of a shape that's not in a regular. We could break this up into like a triangle and a trapezoid and we could find it, but on this particular one they only are asking you to find perimeter. So I just need to find those lengths on the outside, but that also means you need to be able to understand how to find ordered pairs. So I'm going to write next to this one, let's just put some letters on it. We'll say this is A, B, C, D, E, okay? So that will help us when we're doing our work to know what's what. Easy one, ED is 1, 2, 3, 4. Well, I'm going to write that one down. That was nice and easy. Unfortunately, everything else is diagonals, but these two diagonal lines are the same length, and these two diagonal lines are the same length. So although they're not all the same, we're going to make it a little bit easier. So I'm going to write down the ordered pair for, like, let's say C is at 0, 1, and B is at 3, 1, 2, 3, 4, -3, 4. So if I find the length of this, that's also the length of that. So we'll do that over here. BC would be, let's say 0 minus -3 makes it a plus. 1 minus 4. 3 squared is 9. -3 squared is also 9, so that's square root of 18. Let's see what that is. Square root of 18 so the nearest tenth would be about 4.2. Okay, so I'm going to write 4.2 here and 4.2 here. So let's find the ordered pair for D. Let's go -1, -2. So now I'm going to find the length for CD. -1 minus 0 squared plus -2 minus 1 squared. -1 minus 0 is -1, and square that becomes +1. -2 minus 1 is -3. When you square that, that becomes +9. The square root of 10 is about, we'll say, 3.2. Again, these two are the same length, so we'll put 3.2, 3.2. So now we just need to add up all those sides to get our perimeter. So let's see. Okay, it looks like I have a perimeter of 18.8. So using the distance formula to find the length of several of those things, okay? Circumference. Remember the circumference formula and the area formula? This one does say leave in terms of pi. So circumference is 2 pi r, and area equals pi r squared. One thing you'll have to be able to do from a picture like this is figure out where the center is. So let's look to see if we can figure out where the widest part is. Maybe like here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's 10 across there. That would be like its diameter. So 2, 3, 4, 5. This should be its center. Yeah, it has a radius of 5, we'll say. So I figure out where does it hit, like 2 points, or you could do vertically, 2 points and count the distance. So the radius equals 5, so C equals 2 pi times 5, so that would be 10 pi. Area equals pi times 5 squared, so area is 25 pi. Hardest thing about that is probably just finding the center. Next thing we're going to review, also a last chapter thing, is arc length. If you remember the arc length formula, this is the one that you had to memorize from the circles chapter. Arc length equals the central angle over 360. So it's how many degrees over 360 times 2 pi r. Remember, arc length is what goes around the outside of the circle. So this time we're going to get to graph something and look at the picture. We're going to graph the points. I didn't give you graphs because these can be just very estimated graphs. 1, 2, 3, 4, 1, 2, 3, 4. So a point at -4, 0 and a point at 4, 0. So if that represents 2 points on the circle, we need to find the length of the arc. So if you can estimate that, that means the radius of this would be 4 based on that information. You can kind of draw a circle from there to there. Now, it only wants the length of that part. Now, we could draw the whole circle, but it's only wanting the length from this point, x, to this point, y. Okay? It says Z is located at the origin, so that means that's going to be like your center. So this represents half of a circle, so I would say arc length equals 180 degrees over 360 times 2 pi r, which is 4, has a radius of 4. It says, sketch the scenario, find the length of the arc. And we're going to write, I think I'll do it both ways because I'm not sure right at the moment what the way it's asked on the test, but If it asks you to leave it in terms of pi, then this answer comes out to 4 pi. If it asks you to round to the nearest tenth, let's see, if I round that to the nearest tenth, 4 pi would be about 12.56, so we'll say about 12.6. And like I said, right now I don't remember which way it asked on the test, so I'm just going to circle both, leaving it in pi and writing it as a decimal. Alright, the next one we're going to graph these 2 points. 3, 0, and 0, negative 3. So we want to figure out this. Well, we have to decide, well, how many degrees do we think this angle is here? This is a right angle, so we're going to say 90 degrees over 360, which you could reduce that to 1/4 of the circle, times 2 pi, and this one has a radius of 3. So 2 pi, or 2 times 3 would be 6 pi. If you want to do it like this, you could do 6 over 4. You could write it in decimal form. 6 over 4 would also equal 3 over 2. So that's one way to write it. You could write it as like 1.5 pi. That would also work. Or, let's see what that would equal. Or the arc length could equal about 4.7. So if you left it in terms of pi, or if you left it in decimal form. Both choices. The main thing is you realize going halfway around would be 180 degrees. Doing just like a quarter of that would be 90 degrees. So the only other option would do like 3/4 of a circle, which would be like 270 degrees. But I think really the only options we really give you, it's either going to be a quarter of a circle or it's going to be half of a circle to find the arc length. Alright, next one, find the perimeter of the triangle ABC. Now this one's a little bit more unique. So let's go ahead and draw it and I'll explain why it's more unique. So negative 2, 4. C is 1, 1. What makes this one unique is we have no straight lines, which means we have no way to find the height in order to do 1/2 base times height to get area. So what we're going to do is we are going to find all the different sides, lengths of this, because we have to find perimeter anyways. So we're going to find the length of AB. Subtracting our x's. I changed it to a plus sign because we were subtracting 2 negatives. Plus negative 1 squared is 1. Negative 2 squared is 4. So we get square root of 5, which is about 2.2. Fine. AC or BC, we can do that next. 1 minus negative 3 plus 1 minus 2. 4 squared is 16 plus negative 1 squared is 1, so I get square root of 17 this time. That is about 4.1. AB, BC, so AC. 1 minus a negative 2 is plus 2, and 1 minus 4. So that gives me 3 squared is 9. Negative 3 squared is 9. So square root of 18 is 4.2. So my perimeter is, you add them all up. So 2.2 plus 4.1 plus 4.2 equals 10.5 is our perimeter. So that isn't any different from the other side. What makes this one unique is we don't know enough information in order to find area. So we learned something called law of cosines, and here's what it looked like. And it was something, we learned this a long time ago, but it was a squared equals b squared plus c squared minus 2bc cosine of a. Now remember, the a, b's, and c's can kind of be optional, but if we use that same idea, I'm going to write over here on my picture the lengths that we found. We said AB is 2.2, BC is 4.1, and AC was 4.2. Okay, so if we were going to do this, and I want to find, say, A, the big A, so the little a would be 4.1. It would be opposite the big A. So over here, I'm going to do my law of cosines. This will help me find this missing angle, because the area formula we need to use is 1/2 AB sine of C, which is kind of in a general thing. We're going to probably do the one related to the A instead, but let's do law of cosines to find the angle measure first. 4.1 squared equals 2. It doesn't matter which of these I wrote first. I could have done that the other way. 2.2 squared plus 4.2 squared minus, I don't know if I have room, 2 times 2.2 times 4.2. And then I didn't run out of room. Okay, cosine of A. I lost my room. So then you square those things. Okay, so let's take 4.1 squared is 16.81. Let me find a pen here. I'm going to write here 16.81. 2.2 squared is 4.84. 4.2 squared 17.64 minus 2 times 2.2 times 4.2, 18.48 cosine A. Okay, now we're going to add these two things together, and then we're going to subtract it to the other side. So 4.84 plus 17.64 equals 22.48. So when I subtract that, 16.81 minus 22.48. And it was negative 5.67 equals negative 18.48 cosine A. And to get the cosine by itself, or if you remember when you're looking for an angle, we have to use the inverse button. So the way you type that in your calculator, you're going to divide this to the other side. So on your calculator, you're going to type cosine inverse. Remember, you have to hit the second button, and then you divide that negative 5.67 divided by negative 18.48. And that will tell us what angle A is. Let me try that. Cosine inverse. So I have to hit my second cosine. Negative 5.67 divided by negative 18.48 comes out to about 72.1. So we're going to say A is 72.1 degrees. Alright, so this area formula basically says you take, let me put it over here, 72.1. In order to find the area, you want to take the two sides on each side of that angle. So the A and B represent the sides on each side of that angle. So to find area, we're going to take 2.2 times 4.2 times sine of 72.1. And then we're going to take half of that. So I guess I can put the 1/2 in front. Okay, or divide it by 2. We wrote it over 2 sometimes anyways. 2.5 times 2.2 times 4.2 sine 72.1. I have an area of about 4.4. So with that being said, so maybe I should put a note here. I don't know where I can put it. These numbers here represent each side of the angle. So when you're trying to figure out, well, I found all three, how do I know which numbers to use? The A and B here represent each side of the angle you're using. So once you find an angle, you have to pick the two numbers on each side of that angle. Okay? If you look at this formula, it's also the two numbers that were on the same side of the angle in the formula, this formula. So if that helps. Alright, here's your goal. You're going to try this one on your own. We'll start by graphing our points. So we're going to find some distance formulas first. Maybe I'll start those over here. So that is 4 squared is 16. 1 squared is 1, so AB is the square root of 17. Which is 4.1. BC, I'm going to do 2 minus 5 squared plus negative 1 minus 3 squared. That's 9 when you square it. That comes out to 16, so you get square root of 25, which equals 5. Okay, and I got one more left to do here. AB, BC, so AC. Two minus 1 squared plus negative 1 minus 2. That's 1 squared is 1. This comes out to negative 3 squared is 9, so it's square root of 10. So that is 3.2. So I'm going to say perimeter . 4.1 plus 5 plus 3.2 equals 12.3. Okay. So in my picture, AB is 4.1, BC is 5, and AC is 3.2. So if I want to find angle A, we would start that off by saying 5 squared equals 3.2 squared plus 4.1 squared minus 2 times 3.2 is 4.1 cosine of A. we're going to do. 3.2 squared is 10.24. 4.1 squared is 16.81. 2 times 3.2 times 4.1 is 26.24 cosine A. Okay, I'm going to combine these two numbers and then subtract it to the other side, or you can subtract them individually. Okay, these two add up to 27.05. 25 minus 27.05 equals negative 2.05. Then you divide by the coefficient, divide by the number. In front. So you get second cosine, negative 2.05 divided by negative 26.24. So angle A. Angle A equals 85.5 degrees. Okay, so we need that to then use the area formula. The area formula, if we put in here, that is 85.5. To find area, you take 1/2. The sides of that would be 3.2 times 4.1. Sine of 85.5. With that being said, I know on this example I've used a lot of cosines and sines. If you are not in degree mode, it's not going to come out to the same answers decimal-wise as I'm getting, so make sure your calculator is set in degrees. Otherwise, we would be getting different answers on these. So 0.5 times 3.2 times 4.1 times sine of 85.5. Our area comes out to about 6.5. Now, area and perimeter. Perimeter is a lot easier. Finding distance formulas. Area is a little more complicated. We have to use our law of cosines to find an angle, and after we have the angle, then we have to use our law of sine, or our area formula, including sine. So, taking a lot from what we did in those chapters and applying now to the coordinate plane, where you have to graph the points, use the points to find the length, and then find that area.